I am so excited to be here. I actually didn't even think I was gonna be here, and then they let me on the schedule at the last minute. It's so nice of them. I know it's the end of the day. We're gonna make things move around the screen, and like a bunch of things are gonna pop and jazzy things, so hopefully that keeps you entertained. But before we go on, I really wanna thank the organizers for putting together such a great conference. So let's give them a round of applause. Okay, one more round of applause. I need a round of applause for Jen and Ben for being such great MCs. All right, the future of web animation. So usually I get up here and I do something like this. I teach how to make performant animations in the browser and the basics, but it's getting a little boring.
Hey.
Oh, sorry, JavaScript devs. Anyway. So today I want to take us a step further. Today we're going to push the boundaries of the web and what we can do on the web. So before we talk about the future of animation on the web, we first have to talk about what the web is for. The web is first and foremost about communicating. We can communicate happiness and we can share memes. We can communicate fears and talk about politics. And we can educate. But ultimately what the web is for, what we're trying to accomplish on the web, if we really look at it, is communication. So what does this have to do with animation? Why would we need to care about animation in order to communicate? Well, let's think back to your earliest sensory memories. When was the first time that media, not something in your life, but media, made you think or feel any one of those things? Maybe it was Spirited Away. Maybe it was Up. Maybe it was Toy Story. Maybe it was WALL-E. How about something that made you feel all of them?
Boo. Boo.
So we have happiness.
Oh, look at that. Yeah, you know.
You just make me jump.
Oh, that's cute. Yeah.
Now I'm going to
Boo.
like that.
Well, that's very nice. Come here, you. Oh, he's a happy bird.
Yeah, there's biscuits.
We have fear.
Nothing's coming out of your closet to scare you anymore, right? Yeah. Goodbye, Boo.
Kitty.
Kitty has to go.
We have sadness.
Boo.
We have curiosity. You see, emotions attach to our limbic system, making things easier to recall. If I asked you someday when you were 5 what happened on that very day, you probably wouldn't remember. But if I asked you all the words to Hakuna Matata or Under the Sea, you actually might. These cartoons may have seemed like basic line drawings in entertainment, but they gave color and shape to our imaginations and brought life to our internal worlds. And part of the reason why it could do this, what was then so exciting to me and still is now, is that anything can happen. And that's why when we talk about the future of the web and what's possible on the web, and how we can learn, how we can communicate, and how we can share, we talk about animation. My name is Sarah Drasner. I'm Sarah Edo on Twitter. I work for Microsoft. Yeah. I'm also on the VUECONF team and a staff writer for CSS Tricks. And I'm here today to talk about the web's bright future. And we're going to talk about some things that you can do now, and then some things that you can't do yet, and some things that might be coming down on the road for web APIs. So first, let's talk about hooks and reusing pieces of animation across our application. If we want to have a big application where we have animation be consistent across that application, this is a really great way of doing that. However, how many of you in this room have ever had to update a bunch of code because software changed? Anyone? Yeah, like almost all of us, right? Well, this morning, Evan announced that we are moving over to composition components, and so a lot of the syntax of what I'm going to show you is changing. However, all of the things that I'm going to show you today you can still play around with, and the composition concepts are exactly the same. So hooks, or composition components, offer a way to think of reusable patterns, one that avoids rewrites to components themselves and allows us to share stateful logic across an application. We can use that in our animation as well. So I made this food app, and you can see the logo animates, and so does the text as we kind of look at each piece of this application. So the other thing that you can't see as it's doing that is that as soon as one of those things opens, the application freezes so that you can't actually move the window, because we want to make sure that people aren't scrolling around and it's locked in place. So in the source hooks folder, I can create some functions that prevent scrolling, and we're going to import the use destroyed and use mounted, which that's the syntax that's going to change, but it's the same concept where we're going to use those lifecycle methods in a way that we can share them, just like we did with mixins. So we write a bunch of functions that we then call within our use mounted hook, and then we do the same thing with our use destroyed hook. So when we're using it on the component itself, we'll do a similar thing that we would do with mixins. We import, and then we also state that we're going to use it. So this brings up an interesting question. Why aren't we just using mixins for this? So one thing to note about hooks or compositional components and mixins is that they allow us to pass state from one to the other. That's something that mixins can't do. If I have two mixins and we need to somehow have them communicate or compose them together, I can't actually do that. They're not aware of each other. And that's also why composable components is a good name. They also make it explicit where the logic is coming from. With mixins, that's not necessarily true. So let's check out what this would mean with another very basic example from this app applied to animation. So you might have seen that the logo uses this lettering animation, right? And it's similar to what we did for restaurants, but something that we didn't show is that this animation is only present on larger devices, on tablets and desktops, that kind of screen size. And on mobile, it doesn't exist. So at first, in this first hook, we're going to gather some information about the window width, and this is very simple and kind of purposefully so for the purposes of demo. But you can see how this is logic that we might want to reuse. In the second, we'll use a conditional to show different animation logic depending on the window size. So now we can reuse the first hook for different tasks because it's decoupled from one another. So now we can pass the first hook as a parameter to the second hook and compose these pieces together. And that ends up being a very powerful paradigm. So I actually wrote an article about what hooks mean for Vue, and it kind of goes into why they were introduced in React, what they mean for frameworks in general, and dives into some of these concepts if you're interested. There's also a demo and a repo for both of these things. Okay, so without further ado, let's talk about page animations. Page animations are actually something that we're going to build off of through this talk. So these base concepts might seem like, yeah, I've worked with Nux. I know a couple of these tricks already, but stay tuned. Okay, so we're going to make your site a little bit more intuitive using page transitions. The web has come under some criticism in recent years because iOS and Android and kind of mobile experiences tend to have these sleek animations that make everything feel very intuitive to the user, and sometimes the web feels very jarring. Now, what this means is when we recreate page after page all of these concepts, you can see a heat map of an eye going from page after page on the site, and they're having to rescan the whole environment. They're having to look over everything, recontextualize everything, re-understand every element as it comes on the page. So that takes a lot of cognitive load. So how do we reduce this cognitive load and maintain state for the user? So I love this example from Kathy Sierra from Badass Making Users Awesome. If you haven't seen that talk or read that book, she's amazing. So this is a kind of typical stove, right? And I don't know about you, but every time you look at it, you kind of have to refigure out which knob goes to which thing. And if we just change that layout a little bit, all of a sudden, that is remapped, and we already know where everything goes. We don't have to lose those cognitive leaks that we had to impose, and that's just a simple reorganization, right? So recently, Jira made this update where they reorganized all of the information on the page to be clustered in similar areas for this concept. So they went from this to this, and that's a little tough to see, right, what happened between those two. You can kind of get a sense that maybe it's better, but what I thought was really interesting was how they announced it. They actually showed this. This is how they grouped all of the similar types of elements together. And so here are two things. One thing is changing things so that there's not cognitive leaks, but also those animations that keep the state between those two allows you as a person to remap that state, right? Because things in life are moving. You're used to, as a human, seeing things transition. I came onto the stage by transitioning onto the stage. I didn't just like pop up out of nowhere. That would have been very confusing for people and maybe a little scary. So to achieve these effects on the web, we're going to use Nuxt. And Greg gave a really great talk this morning about Nuxt and how to use it. So you already know that it gives you server-side rendering and routing, and you don't even have to step outside of a view file. So in this pages directory, we can do these kind of view files in here and get our routing set up. And we also have this layouts default.view, which all of the pages are going to use by default as the layout. So you'll be given an index in the pages directory. And if you point this, the index page to the other page and use a Nuxt link, this is what you get. It's all set up for you. But there's something more. In Vue, there's a thing called a transition component. And Nuxt knows you might want to make page transitions, so they bake it right into Nuxt. And they make this available to you with a page class hook. So you can make all sorts of animations happen just by using some CSS classes. Or actually, JavaScript hooks are available too. So you can already make page transitions happen. It's pretty easy to make a page transition happen when something's coming on the page. It's not so easy when it's leaving. To pause the page's routing while an animation occurs is actually quite complicated, and Nuxt handles this very beautifully. So you can make things like this. Don't ever make things like this. Don't do that. But really what you can make is something like this. And it's a little more stuttery on this screen. I promise the demo is a little bit smoother than that. But you can see how there's all these kind of more native-like animations from page to page. There are several things that change context, but not so much. We're remapping where that is for each one of those states. And it's also easy to make fully responsive, as we have here as well. So first we'll set up a Vuex store. We're going to store both the page and create a mutation that allows us to update that page. Then in middleware, we're going to update the state by committing it in middleware, and that's where we're going to update it with the current root context. That's how we get a hold of the current root context. And we're going to register the middleware in nuxt.config.js. That's what we need to do in order to use this. So I mentioned that defaults.view in layouts. So what we do is we pass the entire page context into that Nuxt, right there, that Nuxt component. But what this allows us to do in that layouts.default.view, since we're using it on every page, is we can put the navigation, which will be consistent on every page, above it. So I'm actually putting the app navigation component above it, which means it's present on every page. And that means I can also change it, but those elements stay on the page, no matter if we're routing or not. So what we'll do is we'll take this and we'll use this as a conditional for each one of those pages. We'll get from the store what page we're on, and then we can show different content with a conditional, but also move it around. We can also use something called the transition component. It uses flip under the hood. Who here knows what flip is? Yeah, very few. Every time I talk about flip, people are like, I don't know. That's okay. Flip is really awesome because it is a way of getting really performant animations on the browser. We have to use transforms on the browser to make sure that we're not causing repaints. That's what makes them very performant. So what flip stands for is first, last, invert, play. And what we do is we get the coordinates of the first element, the coordinates of the last element, and we invert them, and we figure out the amount of space between them. If that sounds complicated, that's because it is. It's a pain in the butt to implement. And so having this under the hood that we can use just by wrapping it in the transition group is actually a really nice abstraction that Vue offers. So we're going to use that to change a bunch of things at once, because this is really good for like many, many elements at once. So we wrap a lot of the things in that nav inside of that transition group component, and we also create a class that has a transition applied to all of those elements. So every element that I'm going to transition gets the same, that I'm going to change gets the same transition. I don't have to keep applying crazy animations or anything. It basically says, all of you people in this group, you're going to be, anytime you move, anytime you go from one position to another, all of these transitions apply. So you don't have to do a lot of crazy things. It's very declarative. And then we can have per page positioning. So each one of them gets a different position per page. And that's all. You don't have to do really crazy animation logic to get any of these effects to work. It's really, really simple nesting inside of that group. So then you can make these beautiful native-like experiences on the web using Next. So this is the demo, and that's the article if you want to go check those things out later. Okay, here's where it gets really fun. So we just looked at some seamless page transitions and animations on the web, and as you saw, those experiences were also responsive, and by now we're probably all really familiar with responsive design. It's been around for a while. We can accomplish a lot of responsive by making use of what's available to us outside of the box. Like you can use Flexbox, you can use grids, and you can use media queries, right? So what if our websites weren't just responsive in 2D, but 3D as well? What if the browser offered us some basic specs to create experiences like these with ease, just like with Flexbox and media queries? So Josh Carpenter asked himself this, and he was working with this phone, and let's say you have one of these VR headsets that are kind of cheap that you can just plop your phone right into. And so what if at first your page is kind of like a normal web page, but it can look around a bit. But then we kind of think about that scene in a different way. And so this is his kind of proposal of that, and so I decided to make a Next app that did that, using some of the techniques that I just showed you. So I made this technique using those kind of ideas. So it can either detect or you hit the VR, and then you can pan around and look at the scene that you're in as you look around. And it's using those same kind of principles. And I'm also using 3.js. So on the page, we're going to capture the coordinates of the mouse or your headset as it moves. And then we'll update some perspective origin and some transforms on those elements so that they map around to the three-dimensional space and it moves around the same way. We'll also create sphere buffer geometry with our location image as the mesh, basically inverted in a circle. And then we're going to create the camera in the middle of that circle. So we basically stick the camera in the middle of the circle and allow it to pan around. But what's important here is not how it was made with current browser technologies, but how it could feasibly be made in the future if the spec allowed it. So I have a div here. If you wanted to make the div round, what will we use? Border radius, right? That's fairly straightforward. Okay, well, what if we had another way of writing this? What if we had @media VR, and then we could apply some material, like grass? What if all of these end maps and diffuses and things that are really complicated in 3JS were primitives that the web could access? And if you were in a VR environment or an environment that supported more three-dimensional things, you could actually apply it the same way that we apply filters in CSS. So this is a leaked screenshot of the Chrome DevTools. It's what's on the horizon for 3D responsive coming out. If you don't know Josh Carpenter on Twitter, you should check him out. He posts amazing stuff. So here's what we're looking at. We're looking at this detailed view of a chair, and if it's on regular desktop screens or even back, it can be a two-dimensional image. But if you have something like VR, you can actually use the primitives, and those Chrome DevTools will allow us to see simple ways of updating them. So in fact, he was on the A-frame team who invented some primitives that you can make for using 3D experiences. So here's a demo showing the small primitives that make up this more complex scene, as well as a visual inspector, which is kind of like the thing that they're building. So really, you're making all of these with just HTML elements. And it doesn't end there. What if these building blocks were to explore augmented reality as well? What if the browser let us extend what the user was seeing and actually do more and show more using native specs? What if, right now we can accomplish something like this with ARKit, but what if this was available to us in the browser? And think about how it could advance our teaching capabilities. If you have to learn chemistry from a textbook, it's really difficult. You have to memorize all of those, periodic tables. But what if you had more of a visual indicator of how all of these things connect? Remember when I talked about how emotions attach to the limbic system and make things easier to recall? What's easier to recall? Reading out of a textbook or actually seeing how they convert together and create these elements? It reduces the cognitive load to nothing. And you could also apply this to other tactile things as well. What if with the piano, you're actually seeing it mapped to physical space? If you ever played Guitar Hero, it's kind of similar. But those notes are an abstraction, right? Those notes are a cognitive leak in some ways, and this maps them together to what your fingers are actually doing and using. So spatial awareness is really important. How big things are.
All right,
to
who wants to
us,
see a volcano?
how we
3,
are relative to
2, 1. Look at that lava, look at that smoke coming out of that.
Pretend you're an airplane and fly over the tornado.
That's the top of it. What do you see?
It's either asteroid, meteorite.
We're learning about DNA and genes, things that we can't see. And so the most exciting thing for me with the AR technology was that I could see kids get an aha moment that I couldn't get by just telling them about it.
The minute I saw it pop up on the screen, it made me want to get up and walk to it.
We actually get to turn around and look at things from all angles, so it gave us a nice perspective.
See if you can figure out what that might be based on what you know about the respiratory system.
I got to see where the alveoli branched off, and I could look inside them and see how everything worked, which I never saw before, and it was really, really cool.
Because we live in a world that's in 3D. We live in a world with motion. So people often think of these experiences additive, but static 2D is actually an abstraction. It's an abstraction off of 3 dimensions. So with motion and with this kind of exploratory nature of things, we have the friction of understanding, of not understanding how these things play out. So if we're actually trying to look at even just like a product that we're trying to understand if we're going to buy, we can see and feel it and understand what that might be when we purchase it a lot better with that motion. We talked about what you might make when you break out of 2 dimensions. So what can we make when we're even breaking free of all types of input, mouse or keyboard or anything? What can we do when we break out of input methods of the past? So let's talk a little bit about voice-controlled experiences on the web. Many years ago, I hurt my wrist really badly, and I had to relearn how to use a computer by actually speaking to it instead of typing with it. It was very frustrating. So how do we create hands-free experiences on the web? I mentioned I work for Microsoft, and we have some machine learning cognitive services that you can try out for free and just use. My coworker Brian Holt and I were experimenting on a project that connects a Vue application to LUIS, or language understanding, and it can guide visualizations in the browser based on how a person is feeling.
Excited. More. 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 Nervous. Tipsy. Less. Less.
So you can see that I'm actually triggering that with a button click. You don't actually have to do that. You can have it listen continuously. I just don't put applications on the web where I don't get permission from a person first, but you don't necessarily need that. And I'll show you how you do it in just a second. So here's a bird's eye view of the application. We're actually speaking out to Lewis from the VUEX store. We have a bunch of components and a few dependencies, including Three.js. So in a VUEX store, we're going to use a counter to adjust the visualization, and we'll have placeholders for the intent and intensity. The intent is the thing, like the kind of emotional thing that I was saying that I was, tipsy or whatever, and the intensity was the more and less. We're also going to hold a UI state that will initially be set to none, and then later be used to record if it's listening or if it's idle. You might have noticed that we first activated the UI by hitting that button, but after it had found a UI state by listening continuously. So that's that recognition continuous, true or false. So you can also understand, we'll also record what the user is saying by using this get understanding action as well. So in get understanding, we have Axios post to Lewis, and this is open source, so I didn't obstruct the keys here. You can actually just use however you want. And basically, we post to Axios, we pass in our subscription key that you can find on my repo, and there's also the URL that we get. So we'll set the UI state to idle and commit a mutation that changes the state of our intent. So here's what we're connecting to. If you log into the Lewis dashboard, you can create these different intents to train. So you have a model that you're going to train. Basically, you just hit create new intent, and one is made. I really highly suggest namespacing them like this. I do app.whatever for the first thing, and then the second one was intensity.less, so I can find them separately. That's a naming convention now. So we can jump into just one of them. The way that I'm training them is fairly simple. I'm just writing things that are like that thing, right? I'm writing like, I'm fine, I'm calm, I'm untroubled, I'm like Jen, I'm Zen, like her speech earlier. And then you hit the button train, and it will train the model based on those utterances. So once we've created the relationship between the store and the intent, which is the emotion, we're also going to adjust the intensity using the counter that we saw earlier with the phrases less and more. Now in the components themselves, we're going to create a data visualization that will be reflected. So what you're seeing is a Three.js application. So basically you have this torus knot that's spinning in space, and I have this kind of kaleidoscope effect that takes the torus knot. So there's a few different ways that we're updating the torus knot. We're making it go forward and backward for the intensity, and then we're also choosing to have it in wireframe if we're stressed out, or we're applying different crazy colors if we're tipsy, things like that. So just as you can see, we're using these in Vue, so we have all of those mapped to data properties. And I'm also using buffer geometry. If you ever use Three.js, buffer geometries are a little hard to work with, but it's great if you need to tear things down and rebuild it. It's much more performant. So we have several methods that we're using for this visualization, but one I wanted to call attention to is how we're animating it. We're using request animation frame and increasing the rotation as we're re-rendering the scene. And then we'll use a watcher to plug into Vue's reactivity system so that when shape zoom changes, which is attached to the counter for more and less utterances, we can recreate the shapes with the new zoom parameters and cancel the animation and restart it. So what you saw now is the first step. The next thing I'm going to do is actually hook it up to a Muse headset, so you don't even need to say anything at all, and you can control this data visualization with your mind. That's a pretty cool headset if you've ever checked it out. So now we can communicate hands-free with the web and have animation guide us. Super cool. So we already accomplished so much, and there's so much we can do out there. The web is open with all of these opportunities, with all of these things we can do and create and make. So why do I feel like, as Jen Simmons eloquently puts it, that we're in a rut shaped like this? Why are we making sites like we have static table-based layouts when we have all these opportunities to share on the web? Jen's not the only one who noticed that this tweet resonated with a lot of people. We make the same sites again and again, and none of them are very memorable. Remember how emotions attach to the limbic system? how are people going to remember the site that you're building if they feel nothing when they go to it? It's time for us to take up some space. Hopefully, some of the things that I show you today are going to become beautiful primitives in the web of tomorrow, but I made them with technologies that are available to you today. All of this stuff is still open. It will just get easier as time goes on. It's time to expand our minds and beyond the rectangles of the past. We all have room in our digital lives to take up more space. And as we noted before, anything's possible. So my question for you today is, what are you going to build? So my hope for us is to think bigger. The shape of our rut in the web all looks the same. How can you in your everyday development life push the boundaries of what's possible? How can you create something that doesn't currently exist? How can you make your dreams out of code and share it on the web? Because after all, that's what the web is for, to invent, to create, and to communicate. Thank you.